Hi, my name's Steve Hooper. I look after our business strategy and marketing for our design and manufacturing portfolio. Let's talk a little bit about what Autodesk does. At the core of what we do is our vision and our mission, which is to help people create a better world. And to do that, we need to empower them with tools and technologies that lower the barrier to entry so that more people can participate in the process of design and manufacturing great products that change the way that you and I live our lives. So when I was a student and I went to school, I really went there with the understanding that once I'd qualified in my profession, I would join industry as a practitioner, working for somebody else to help bring their ideas and concepts to life and take them to market. Now, things have changed. You know, if I look at people that I meet and work with in the marketplace today, most of those people that are coming into industry, they don't want to work for somebody else so much as create their own vision and find their own path in the world. And what I find inspiring is that we see a convergence of trends that are really helping people lower barriers to entry so that they really can pursue their own career and lead businesses of their own and take their own products to market. So let's start by talking about some of those trends that we see in the marketplace. Most people, when they develop products, think of the traditional product life cycle from concept through engineering, manufacturing, to sales, use, service, and eventually end of service or end of life. But the ability to be able to connect to a product and gather data about its usage turns that linear process into something that's more cyclical, iterative, agile, that enables you to iterate on a concept and create more innovation in what you bring to market. And these two trends, the ability to be able to connect data and change the way that you manufacture products, also means that we're starting to be able to employ things like machine learning and really understand or leverage the computer to develop more interesting, innovative concepts where machine learning algorithms actually assist designers and engineers in how they do their job. So if you think about 3D modeling as a concept, as a discipline in design and engineering, you can see that in this case, actually the beauty of this product, its innovation, doesn't lie in the industrial design or the 3D model, which is relatively simple to represent. It's actually the intelligence that's embedded in the electronics and its connectivity to the cloud and their ability to use machine learning to analyze that data and make more informed predictions for store owners. And that tells you a lot about how people are going to differentiate products with smart connectivity in the future. And that's something we're learning on as we start to develop the tools and technology you use to bring your ideas and concepts to market. Modbot are revolutionizing the world of robotics. They've taken a 6-axis robot to market in the space of just 6 months across 6 different geographic locations, across 6 different disciplines when you think about electronics, software, industrial design, mechanical engineering, and so on. And so that's an incredible challenge for a small startup company to embrace, but they've done that because they've been able to use our tools and technologies to build a single digital representation of the product that they're bringing to market. And the power of the cloud enables them to connect these different disparate geographic locations together so that they can operate in unison as one organization. So let's talk about the means of production and how they're changing and evolving. The example that I'm going to show you here comes from a company called Ramlab. Now, Ramlab are responsible for the repair and servicing of large vessels, cargo ship containers. And for each day that a cargo ship container spends in port, it costs about $1 million in lost revenue. So if a propeller blade breaks on one of these cargo ships, it's critical that they're repaired as quickly as possible. And what you can see in the video is that Ramlab have used this next generation production technology, in this case high rate deposition, to allow them to use a 6-axis robot to literally 3D print a propeller blade and then finish machine it with conventional multi-axis subtractive machining. They're able to manufacture at the point of demand with a physical asset that meets the needs of that vessel within a day. So that's a huge change in the way that you design, because as a designer, you're traditionally taught that it costs more money to remove material from stock inventory, and so you should try to maintain a design as close to stock material as possible. But when you start to employ techniques like additive manufacture with metals, actually the more material you leave in the manufactured part, the more expensive it is to produce. So it actually turns some of those conventions upside down, and that means that you as a student and as a practitioner in industry need to rethink and relearn the way that you approach design. We employ a technology called generative design. In the example I'm showing you here, we employed that generative design technology with Airbus to help them with their next generation of aircraft fleets. They have a corporate objective by 2050 to reduce 50% of CO2 emissions, and so they need to be able to lightweight their aircraft of the future. And so we're working with them to evolve and adapt generative technology to help serve that need. They decided they wanted to take generative technology and apply it in their existing product lines to experiment with it in real aircraft conditions. So the example that you see on the screen is actually a bulkhead from an aircraft today, which the steward's jump seats are attached to for aircraft takeoff and landing. It's important that they stand up to FAA regulations, and this provided an ideal opportunity for Airbus to test that concept out. And so they leveraged generative design to fully explore the solution domain. If you imagine a simple engineering problem has maybe 3 or 4 variables that you can change as you start to meet the market requirements that you as a designer are trying to serve. Things like material, displacement, loading, the support structure, how you assemble the product, what manufacturing technologies you use to produce this product can all be varied to meet the market requirements you're trying to solve for as a designer. Now, our generative technology leverages the power of the cloud to be able to parallel compute thousands of different iterations that span that solution domain, and then we provide visualization technology that you can see on the screen that allows you to pivot different design properties like displacement, stress, material, manufacturing technique, volume, weight. And as you pivot these different properties, you can look at the different results. And the generative algorithm will help identify maybe the top 10 possible results depending on the different market requirements you might be trying to solve for. So it doesn't replace a designer. What it does is it automates the process of defining the 3D geometry, and it puts the power back in the designer's hands to do their core job, which is to make trade-off decisions based on market requirements and manufacturing constraints. So generative technology really represents an investment that Autodesk is making in the future of manufacturing and design. So let's talk a little bit about connectivity, because there's this massive pool of information that you can make use of as a designer to help better inform the designs that you create. Now, that information comes in a variety of different forms. It can come from the design process itself. It can come from RFQs logged by customers at the purchasing phase of the product development process. But it can also come from products out in the field and from your own manufacturing processes. So for every piece of manufacturing equipment you use in your production facility, huge amounts of information are being generated every time you run them, which you can tap into to make more informed decisions about not only the product's design, but the manufacturing process that you'll employ to produce it. Human beings will work side by side machines. And our belief is that that exact same transition is going to happen to the design and manufacturing market. And it's a process that we call push-button manufacturing. It doesn't simplify manufacturing. What it does is it automates the parts of the design and manufacturing process that are formulaic and process-driven, and it means that human beings will spend their time and effort in the creative process. And that's really what our company stands for. It creates the opportunity to empower you as the individual to take this technology and apply it in a way that literally allows you to make anything. Thank you.